Hi, I'm Zahid Haq and want to welcome you to my Fate of Lactate presentation. Okay, so here this diagram here shows the Cori cycle, which is involved in the exchange of lactate and glucose between muscles and the liver during anaerobic exercise. In the muscles, the glucose is broken down into pyruvate, which is then converted to lactate due to limited oxygen. The lactate is transported to the liver where it's converted back into glucose through gluconeogenesis. This glucose is released into the bloodstream and taken up by the muscles for energy, and thus completing the cycle. The Cori cycle is essential for maintaining blood glucose levels during intense exercise. The high intensity exercise increases lactate production due to anaerobic glycolysis, which is transported to the liver for conversion back into glucose through the Cori cycle. Endurance training enhances the body's ability to use oxygen efficiently and reducing lactate production. Training also improves lactate clearance and the liver's capacity for gluconeogenesis, and making the recycling of lactate into glucose more efficient during prolonged exercise. Now, the differences between the lactate and lactic acid. In the chemical form, lactic acid is the form that includes an extra hydrogen ion. So in simple terms, it's a temporary molecule that quickly breaks down into two parts, lactate and hydrogen ion. And this happens because the body's pH balance doesn't allow lactic acid to stay in its original form for too long. The presence in the body, lactic acid is present in the body, but only for a short time because it rapidly turns into lactate. Lactate is what we commonly find in blood and muscles, especially during exercise. So when we talk about lactic acid during a workout, we're really talking about lactate. The role in exercise, many people do believe lactate causes muscle fatigue, but this is actually a misconception. In fact, lactate is an important fuel during intense exercise. The real issue comes from the hydrogen ions that are released when lactic acid breaks down. And these ions actually make the muscles more acidic, which can interfere with the muscle contractions and contribute to the feeling of fatigue. It's easy to confuse lactate with lactic acid when discussing muscle soreness or tiredness after exercise. But lactate itself is not harmful. In fact, it helps provide energy. The problem from hydrogen ions released during the process, which can lower muscle pH and which can affect muscle function. The lactate use in metabolism and its impact on exercise sustainability. Lactate produced during glycolysis serves as a fuel source and can be converted back into pyruvate for ATP production or into glucose via the Cori cycle in the liver. However, lactate accumulation leads to metabolic acidosis and fatigue when it exceeds the body's clearance capacity. So regular endurance and high-intense interval training improve lactate clearance and increases the lactate threshold and delaying fatigue through adaptations like higher mitochondrial density and better lactate transport. In regards to the cellular factors influencing exercise cessation, exercise cessation is driven by various cellular factors. Prolonged activity depletes muscle glycogen, reducing the ATP production and limiting energy for muscle contractions, and therefore leading to fatigue. The accumulation of byproducts such as inorganic phosphate, hydrogen ions, reactive oxygen species disrupts the muscle function by lowering the pH levels and impairing the enzymes and causing oxidative damage. Disruptions in calcium release and uptake with muscle cells weaken the contraction force, while neuromuscular fatigue caused by inadequate central nervous system drive and reduced neurotransmitter levels further contribute to the fatigue, especially during long endurance activities. And that's it. That's my presentation for the fate of lactate, and hopefully I've explained it well, and it's been interesting dynamic to learn. Thank you.